2018, exercise number 2. The aim of this exercise is to study the effect of resistance of a resistor on the charging of a capacitor. So we're working on charging. So this is why we have a capacitor of capacitance C equal 4 microfarads. We have a resistor of resistance R, and we have a battery of voltage UAM equals to E, and a switch. So we close the switch at T0 equals to 0, and the charging process starts. First part, derive the differential equation that describes the variation of UC during the charging. So one differential equation in terms of UC. So now we always start with the law of addition of voltages. So law of addition of voltages in series, which will get UG equals to U of the capacitor plus U of the resistor. Now here, this is equals to E, this is UC, we want it in terms of UC, but we know that UR, according to Ohm's law, is equal to R times I, where in the case of a charging, we have I equal dQ over dt, and Q is equal to C times UC. So this means I get as current I equals C duC over dt, which means that here UR will be equals to R times C duC over dt. So we divide all the equation by RC, and we'll get duC over dt plus UC over RC is equals to E over RC. And this will be our differential equation, first order differential equation. The solution of this differential equation has a form UC equal A plus B e to the power dt. The question is to determine the constant A, B, D in terms of E, R, and C. So first of all, had the solution and differential equation. So we'll write the differential equation that we obtained. So طلع معنا duC plus UC over RC is equals to E over RC. When we say that this is a solution, this means that it verifies the differential equation. So UC we have it, but we still have to find duC over dt. So UC equal A plus B E dt. By deriving, with respect to time, A is a constant, so 0. B E dt would say B d times exponential dt. And then now we substitute. So we'll get B d. And plus UC, we'll put all this part here. So it's A over RC plus B exponential dt over RC. And minus E over RC is equals to 0. So شفنا هيدي لهون. Now شو بنعمل؟ we take كل شيء فيه common factor، كل شيء فيه exponential بناخذ common factor. So we'll get this means E dt, and we also have B as common factor. So بقى لنا D and plus 1 over RC. And another way, I take the part اللي باقيين ما فيهم exponential مع بعض. So I have 1 over RC as common factor and A minus E, which is equals to 0. And then now here we continue. This means that D plus 1 over RC is equals to 0, which means that D equal minus 1 over RC. So طلعنا أول unknown. And the second one, A minus E is equal to 0, which means that A is equals to E. Now we still have to find B. So now we'll go to the initial condition, which means at T equals to 0, the capacitor was uncharged. This means UC was equals to 0. So by substitution here, we'll get 0 equal A plus B e to the power 0. This is equals to 1, which means that B is equals to minus A, and A is equals to E. So this means that B equal minus E. And here we go, we find the 3 unknowns. So the equations, the mathematical equation side of this form, UC equals E minus E, E minus T over RC. This is the solution. Now, part 3, verify that the capacitor becomes practically fully charged at T equal 5 tau, 5 RC. So we have to verify. In order to verify, so we'll substitute. So at T equals to 5 RC, I have UC equal E minus E minus, so instead of T, we'll substitute RC, so equal 5 RC and over RC. We simplify, so it's equals E minus E exponential minus 5. This will give us as answer using the calculator. So if we take E as common factor, this will be equals to 0.99 E, which means that it becomes practically fully charged. Part 1.4 indicate the effect of the resistance of a resistor on the duration of charging of a capacitor. So the duration of charging of the capacitor is T equal 5 RC, and it depends on R. So we notice it depends on R. This means each time I have R is higher, so when R increases, if R increases, this means the time of T of charging increases, which means it will charge slower. So the time of charging increases implies it will charge slower. Part 2, experimental study. We adjust now R to two different values, which are R1 and R2. An appropriate device allows to trace for each value of R the voltage UC as function of the time. So this is UC as function of time. For curve A, I have R1. This is R1 here. This is when I use R1, but this is UC. This is the graph of UC. And the graph of UC when I use R2, that's it. Using the curve of document 3, specify the value of E. So this is part 2.1.1. So according to the graph, I have UC, but we know that UC maximum is equals to E, which means it's equals to 8 volts. Now, we continue. Part 2, specified without calculation whether the value of R2 is equal, greater than, or less than the value of R1. So I want to look at R2. If I look at R2, R2 becomes fully charged after R1. It needs more time. So لساعة full charge كانت وصلت لهون. This means كان بدها وقت أكتر. So this means that here we already said that in order to become fully charged, T equal 5 RC. And we notice that T, to become fully charged, T of the curve B is higher than T of the curve A. أخذت وقت أكتر, let's say fully charged. Which means, and we know that T and R are directly proportional, which means that R للfigure B is bigger than R of figure A, and that of figure B is R2, which means that R2 is bigger than R1. So this is for the without calculation. Part 2.1.3, determine the values of R1 and R2. And to determine the values of R1 and R2, what should we do? We should here find, we have C, we already have the capacitance, which is equals to, so can minus C equal to 4 microfarad. C equal 4 microfarad, which means equal 4 times 10 power minus 6. And لما بيعطينا graph, this means I must use tau. So how should we use tau? We know that in the case of charging at T equals to tau, so we'll take first figure A. So at T equals to tau, we know that UC must be equal to 0.63 E, which means equal to 0.63 times 8, since 8 is equals to E, which means that's equals to 5 volts. And then now I look at the figure. This is the 5 volt. If for the figure A, if for the graph A, I will notice that tau, this is the value of tau, so tau equals 0.4 millisecond. So this implies I have tau 1 equal 0.4 millisecond. But we know that tau is equals to R times C, which means that R1 times C is equal to 0.4 times 10 power minus 3. And we have C, which means that R1 is equal to 0.4 times 10 power minus 3, and over C, which is equal to 4 times 10 power minus 6. And then the answer of R1 will be equals to 100 ohm. This is the value of R1. Same thing, but for figure B. For figure B, at T equals to tau, I have UC is equal to 5 volts also, the same thing. But if I notice, I will take now the second figure, the second graph. So this is 5, here we have 5. So tau 2 will become equal to 0.8. So this means tau 2 is equal to 0.8 milliseconds. Tau 2 here, R2 times C. And then I get R2 is equal to 0.8 times 10 to the power minus 3, and over C, which is 4 times 10 to the power minus 6. And here then the answer will become R2 equals to 200 ohm. وهيك بنكون كمان بيهمنا إنه yes R2 is bigger مثل ما كنا قايلين بالبارت اللي قبل. The last part, the capacitor is fully charged, so the electric energy stored in the capacitor is WC. Is the value of WC affected by the resistance justified? We already know that the energy across a capacitor is of the form half CUC square. So it does not depend on R. So not affected by R since it is independent of R. Now, deduce the value of WC. So now we can find the value of WC by saying equal half CUC square, but we are saying it's fully charged. This means UC is equals to E. So we'll get half C times E square, and E equal to 8 volts, so equal half 4 times 10 to the power minus 6 times 8 square, and this will be the value of the energy. So it's 1.28 times 10 to the power minus 4 joules.